Hi, my name is Methane Mike Doran, and today I want to talk a little bit about tropical storms and the electrics or the electrical behaviors inside them. I want to first give out a shout to Sean at weatherbb.com. Him and I go way back. He's a storm chaser. He's interested in how storms are at the place of the storm. And I was joking with him the other day that I'm interested in how the storms work from the outside in. He's interested from the inside out. I guess it's an interesting contrast. But he's landlocked in Illinois, and here I am out in California, interested in tropical storms, which are in the tropics, and the electrics behind them. There's quite a bit of new research that's come out, particularly with the ability now through the use of multiple stations to pick up where lightning strikes occur globally. That research, one of the more interesting studies that just came out from Israel, looking at the past 80 tropical storms around the world, turns out all but 2 of them, 24 hours prior to them rapidly intensifying, there was an increase in global strikes. The 2 that were the exception to the rule, you could easily argue that near them, not globally, there was likely an increase in strikes. And so near the storm in general, the potential difference between the upper atmosphere and the earth increased, because every time lightning occurs you get charges that go down to the ground, and those charges have to come from somewhere, and they maintain a potential difference where there's positive charges in the upper atmosphere and there's negative charges below. Why would that matter? Well, that matters because it makes the upper atmosphere more positively charged, and the more charges there are, the stronger the field, the more likely that you're going to get actual movements. Well, I want to just, as a son of a meteorologist, my interest in electrics is prediction. When my father was a meteorologist, it was a lot more simple. They didn't have computer models that they have today. They would chart a front where it was and then see where it was going and try to predict then down the road what weather was. They didn't have computer models or anything like that. What I'm trying to do is look at what potential electrical conditions are, and then from there try to figure out whether a tropical storm is going to rapidly intensify or not. What's the state of the science? Well, Dr. Avila at the National Hurricane Center, who's a lead forecaster there, he says that you cannot forecast intensification. You can only call it. It's an interesting view, and I think it does accurately reflect what the state of the science is, that they are having a lot of difficulty predicting when a storm will rapidly intensify. What they do know is that when there are a lot of strikes inside the core of a storm, it correlates strongly with a rapid intensification. Now, tropical storms in general have very few strikes, and the reason for that in theory is that unlike a thunderstorm where you have these clouds that are raising and then downdrafts, and you have movements of particles and friction where charges can be created and then separated, that's how lightning occurs in a thunderstorm. But a tropical storm has a much different structure to it, and where the ice is and where friction would be taking place is not the same. You have a disk of clouds of ice particles that trap heat, don't let it get released out, and you have different layers of clouds and so forth. There's less lightning in it. Exception would be these hot towers and maybe around the edges of a tropical storm, but even there the edges behave more like thunderstorms anyway, and the hot towers are just a very unique part of a tropical storm. And this is where the core strikes occur that indicate a rapid intensification. Now, what a lot of people have said is that just because you have core strikes doesn't mean that the lightning is causing the intensification. In other words, what they say is the hot tower is just a place where lightning occurs, and when a storm rapidly intensifies, it creates the lightning, not the other way around. That there is no value in looking at the tropical storms to see if the lightning causes the intensification, because they argue that the storm itself causes the lightning.